Welcome everyone. In this video lecture, we will discuss a very fundamental concept of stick diagram of CMOS circuits, their theory and the examples. Okay. So first of all, what is a stick diagram? So basically a stick diagram is used to represent a CMOS circuitry and their topography and their layer information using some colorful straight line. We will discuss what color should represent the metal, the NMOS polysilicon layer, the N plus diffusion. We will discuss it later. So colorful straight line is a stick. So basically it is used to represent a CMOS circuit topography and their layer information using colorful straight line as a stick. Okay, so it is different from the layout diagram, or in fundamentally we can say this one is a the stick diagram is very simple. We can say a rough, okay, a rough sketch, you can say a sketch or representation of layout diagram is nothing but simply a stick diagram. What I am saying, a rough sketch of layout diagram. For example, one simple one, I am just saying, for the NMOS layout. Okay, if suppose we have to make a NMOS layout, so I think many of you may aware of this. So what we have to do, we have to make a N plus region, N plus diffusion region, okay, and along with one polysilicon. Okay, so this one is a layout diagram for NMOS layout. Okay, so this green one is called our, okay, this green one, okay, this green one is called our N plus diffusion. Okay, and this red one is called the polysilicon. Okay, this one is a simple representation in a layout representation. And very simply, the in a stick diagram, we have to just make like this: one green one, okay, and one red one. Okay, this one is NMOS layout representation. Okay, I'm writing here. Okay, and try to make a boundary here. Okay, and this one is our, what we can say, the stick representation. Okay, so again this one is called our polysilicon polysilicon, and this one is called the N plus diffusion line, or N plus diffusion. Okay, so basically this may be also drawn like this red and green. Okay, first we will go for the, then I will say what color, we will discuss it later. Okay, it may be like this also, means this one is our, what we can say, the green one is a N plus diffusion, and this one is also our polysilicon. Okay, both are same and both are NMOS representation. NMOS, I am writing here, NMOS stick representation. Okay, now today we will discuss the stick one, not layout, but here it is in terms of blocks, and in stick it is just in terms of line. Okay, so in this one is for the all NMOS representation. Okay, so polysilicon is basically this red one is a polysilicon is having a red color, and this green one is a N plus diffusion region. Okay, so basically transistor is replaced by a block in layout, and transistor is represented in terms of a straight line in a NMOS stick representation. Okay, so here one thing I want to show that this red one is our, we have to say this one is a get in. Okay, this one is a get one, or polysilicon will, this one is a gate one. Okay, after left and right, either it should be source, I am lighting, source region or drain region, or it is symmetrical device, so it may be either drain and source. Okay, source drain. So here what we can also write, either it is source or drain, or if this, we say this is drain and it is source, like this. Okay, so that we have to know. Okay, so this is the, what we can say, the NMOS layout representation. Okay, NMOS layout representation is block, so we are not discussing too much about. But in case of this stick representation, the red color represents the red color represents the polysilicon. Okay, and the green color is the N plus diffusion for the NMOS. Okay, one more thing, the PMOS. Okay, so here I am just making a line. Okay, so for PMOS layout presentation. Okay, so in case of PMOS layout representation, okay, one polysilicon will be there. Okay, so I'm making one polysilicon, and P plus diffusion region having the yellow color, so it should be like this. Okay, so again, this one is your polysilicon. Okay, so, and this yellow one is our P plus diffusion. Okay, it may be tilted. Okay, so but this one is the representation. Okay, similarly we are discussing about the layout inform stick representation. It may be one polysilicon line and one yellow line will be there. Okay, or we can make like this. Okay, so this one, yeah, red one is our polysilicon. Okay, red one is polysilicon line, and this yellow one is our what, P plus diffusion. Okay, so this one is our P plus diffusion. So this one is our PMOS layout, sorry, PMOS stick representation. Okay, PMOS stick representation, this one. So I'm writing here. Today we will make the layout, sorry, stick diagram for the CMOS inverter, but we have to know the this basic. Okay, so this is the polysilicon and P plus diffusion. So now we have to go for the very fundamental or basic thing, means what color represents what information. So stick and layout diagram representation. Stick diagram and layout diagrams are are basically represented with colors. Colors. Okay, different colors. Okay, so I am writing here layer information, okay, and here the layer color, okay, or layer color or representation can say, okay. So now I'm just making one line over that, okay. So the very first thing in any CMOS circuit, the first thing is our metal. So metal layer is represented, the metal layer information is represented with a blue line. So a blue straight line. Okay, so this one is basically a blue line. Okay, so I am writing in blue line. The second one is our polysilicon. Okay, so better to take red color because for the polysilicon we have to use the red color polysilicon. Okay, so I'm using a red line. Okay, now the third one is our N plus diffusion. So for the N plus diffusion, we have to use the green color. So I'm writing with a green color. So this one will be the green line. Okay. Now next one is our P plus diffusion. P plus diffusion. For P plus diffusion, we have to use the yellow line. Yellow line. Okay. Now the another important thing is our contact. For contact, we have to use a black dot, okay, which is basically to connect different different layer. Okay, in addition to that, one more important thing is there. What we can say, the uh, sixth one, having brown color, means demarcation line. Demar Demarcation line. Okay, so demarcation line is basically a dotted line. Okay, so it is used to just separate out the NMOS and PMOS, to separate NMOS and PMOS. Okay, I'm writing here to separate NMOS and PMOS in a CMOS circuit. CMOS circuit. Okay, so these are the six different colors. Okay, represent several information. Okay, once again I am repeating. For example, the metal line is represented with the blue color. Okay, metal line is represented with the blue color, and the polysilicon line will be used as a red color, and N plus diffusion with green color. Okay, green shade line, P plus diffusion yellow, contact black dot. Okay, and demarcation line is nothing but simply to separate NMOS and PMOS. So this is one important information. Okay, now we have to also deal with the different rules. So for the NMOS, we have already discussed. Once again, for NMOS, for example, once again here I am writing a quick view for NMOS. Okay, suppose NMOS we have to make. So we have to make a polysilicon, okay, and one green color. Okay, it may be like this also, red color, green and red. Okay, both are means pairs. NMOS. Okay, this green color is N plus diffusion. Okay, and red one is our polysilicon. Now if we will say PMOS, PMOS. Okay, so in PMOS, one red color. So, okay, this all are PMOS. Okay, clear. And there we don't have to put a dot. Okay, otherwise it will wrong. So red over the green, green over the red. Okay, so PMOS. Okay, now these are the enhancement one. So NMOS transistor, if one important one, NMOS transistor, mm, depletion, with depletion can be supposed to NMOS. So first we have to make the NMOS red polysilicon line, green line. Then we have to use a yellow color. Okay, this one is our NMOS transistor with a deflection mode. Okay, first we are making red over the green and one yellow box. Okay, so this is the some fact. So I have already discussed for the NMOS, the red color, this red color is polysilicon, polysilicon. Okay, this red, this red, this red. Okay, and green one is our N plus diffusion. Okay, once again I am writing N plus diffusion, N plus diffusion, you can say diffusion, this green color, this green color. Okay, and this one yellow one is our P plus diffusion. Okay, so this is all about the simple representation. Okay, so now we will go for some basic rules. Okay, rules of a rules for a stick diagram means the rules. Okay, so this one is, then we will write here rules to draw a stick diagram. Okay, this one is also very important. Rules, few rules are there. Basically, four rules are there, and very simple rules. So we will also go through that the theory. Then we will today we will draw the CMOS inverter layout, stick diagram, not layout. Sorry. Okay, so rules to draw a stick diagram. So I am writing here rule one. Okay, when sticks, two or more sticks having same color, I am writing means, for example, suppose two metal, for example, two metals are there, it is connected like that. Okay, or two polysilicon having the same color. Okay, this one is two polysilicon is intersect, and this one is two metal wire are inserted. So when two or more sticks having same color, or and they touch each other, they represent electrical contact. So there is no need to put some dot. Okay, that all are connected. So rule one, when two or more sticks of same color touch each other, when two or more sticks of same color touch each other. Okay, that represents electrical contact. Okay, means if two polysilicon is there, it is connected. Okay, electrical contact is there. Okay, now rule number two. In rule number two, when two or more sticks having different color intersect each other or touch each other, they are so there is no electrical connection. So I am writing here. Okay. When two or more sticks of different colors colors cross or touch each other, it means there is there is no electrical connection. Okay, so what it means, if some red is there and blue, okay, it doesn't mean that it is connected. Okay, it doesn't mean it is connected. Electrical connection is not there. We can say electrical connection is missing. Connection is missing. But here when having the same color, they are electrical contact. Same color, there are electrical contact. Electrical contact between them. Okay, this is rule number 2. Now we have to go for the rule 3. Rule 3. Okay. So in rule 3, when polysilicon crosses the diffusion layer that represents the MOS. Okay, so it is very important. I'm writing that I have discussed the NMOS. When polysilicon crosses, we know this rule, but diffusion layer. When polysilicon crosses diffusion layer, it represents MOSFET. It represents a MOS structure, either PMOS or NMOS. For NMOS, but some polysilicon is there. Okay, and if green color, it is NMOS, and if yellow color, it is PMOS. Okay, so this one is our PMOS and NMOS. This one red color polysilicon, N plus diffusion, P plus diffusion. Okay, now rule number 4. Rule number 4. Okay, so in rule number 4, draw a demarcation line to separate PMOS and NMOS. They are very simple. 4 rules are there. Okay, NMOS and PMOS realization. For example, one PMOS is, we are making a PMOS. Okay, so for PMOS, I am writing. Okay, and NMOS. Okay, so there will be a demarcation line. So this one is our NMOS and PMOS. and this one is our demarcation line. Very simple. So means what we are doing, four rules are there. Fundamental, the very first rule, when two or more sticks are having the same color, touch each other or intersect, that represents a electrical connection. Okay, that are connected. Okay, when two or more sticks of different colors cross each other or touch each other, it means there is a no electrical connection. So if we have to make connection, we have to put a black dot. Okay, when polycycle crosses N plus diffusion or P plus diffusion, it represents NMOS or PMOS depending upon the different color. For green, N plus diffusion, yellow, P plus diffusion, and demarcation line we have to draw to separate PMOS and NMOS. So this one is one example. There's the four rules, and these are the four different layer information. Their color: metal blue, polysilicon red, N plus diffusion green, P plus diffusion yellow, contact dot. Okay, and demarcation line this. Okay, so this is some basic thing. Now we will go for the one example. Okay, stick diagram of CMOS inverter. Okay, so we have to go for different page. So I am writing here CMOS inverter stick diagram. It is very simple stick diagram. Okay. Okay. So the very first thing, to draw the stick diagram, we have to first know the structure. How to draw the simple CMOS inverter structure. So first I am making the CMOS inverter. We required one PMOS. Okay. That you have to know is how to draw. These two are the gate terminal connected together. This one is our VDD line. This one is ground, or sometimes say the VCC, and this one is our V output. Okay, and V in. Okay, means V in, V output. So V output is nothing but V in complement. Okay, V output is nothing but simply the V in complement. Okay, so this one is our structure. So we have to know this one is our PMOS. Okay, and this one is our NMOS. Okay, the arrow sign always show the source terminal. Okay, arrow sign always show the source terminal. So this one is source of PMOS, gate, drain. Okay, this one is also source of NMOS. Okay, I'm writing a G of gate of P, source of P, drain of P, source of N, gate of N, and sorry, drain of NMOS. Okay, so this one is the very fundamental CMOS circuitry. Okay, so the very first thing in any stick diagram, what we have to make, first we have to make a PMOS and NMOS. So what we can do, first make a PMOS. Okay, so for PMOS what we can do fundamentally means we have to draw the stick representation. So what we are doing, some PMOS representation. So PMOS with yellow line and one red color is our simply the polysilicon line. Now this one is our PMOS. Okay, how see I am doing. Okay, similarly for the NMOS, what we can do, there will be green line. Okay, as a N plus and one polysilicon. Okay, so this one is our NMOS. Okay, at the end I will show how to make, but first PMOS. Okay, now this, okay, means this one is our gate. This red one gate of the PMOS, and this one is a gate of the NMOS. So this gate terminal of P and gate of N is connected together. So one can means as a layman, what we can do, we can connect like this, okay, and we can say this is our V in, yes or no, get, and this one, the above one, will be, we can say this is our source of P terminal and drain of P terminal, we can say, because this line source get, then source and drain. Now this one is drain of N. So what we can write here? This one is our drain of N, and this one is our drain of, sorry, sorry, source of, this one is our source of N terminal. Okay. Now say these two are connected. Okay, these two are connected through a metal or directly connected. So I am saying these two are connected with some metal. Okay, so I am just making some metal connection. So if two different wires, different colors, so we have to use contact. So I am making like this. Okay, clear? Now what we can do for just simplification, I am just increasing this line. Okay, now the source of P is connected to supply. For the supply region, we have to draw a metal line. So one metal line will be there. Okay, and for the ground one also some metal line will be there. So this one is called our VDD line, and this is our VSS, or simply we can say the ground line. Okay, and there is a electrical connection, so we have to make, and this one electrical connection. So this should be our simply V output, which is our simply V in. Here we are not putting any dot, okay, because they are same color. We are assuming that this one is our, what we can say, this one is our transistor. Okay, this one is transistor. Okay, after that there is metal kind of thing. So metal. Okay, so this one is our representation for the CMOS inverter. Okay, this one is our CMOS inverter. One can also draw like this by using just VDD here, VDD here. Okay, and then after PMOS we can make an NMOS, like that we can do. Okay, so this is one way. So basically in this one we have to reduce the, one more thing, we have to reduce this polysilicon line. So one another example is also there, means another way how to draw. So what steps we have followed? First we have make the PMOS here, then we have to make a NMOS. Okay, for PMOS what we did this, and for NMOS, okay, okay, first do the PMOS. So we can make like this. For NMOS again with green color. Okay, we have used for VDD or VSS line, we have to use a yellow color line. So this yellow color, for two different colors we have to use a contact. Okay, so this is the way. Okay, so now in this case there are so many red color are used, the polysilicon. So in uh, layout information it is observed that the polysilicon will be very less. Okay, below 14% we have to use the polysilicon. So another way to how to just draw, so what we can do, the same thing we can do like this. Very first we have to use a metal line. For example, we are just making the metal line like VDD and VSS. Okay, then after for the PMOS representation, okay, we are making like this, and NMOS representation we are just, and this red line. This red line is nothing but simply will give you the V in. Okay, and this one is a gate of NMOS we can say, and this one is gate of P, and this one is our source of P terminal and drain of P terminal, and this one we have to just after practicing source of N terminal and drain of P terminal. Okay, then after what we can do, this drain of P and N are connected, okay, through a metal line. So what we can do, okay, we just submit to this. Okay. So what we have to do, we have to make a electrical connection. Okay, here also we have to make some electrical connection. So put it dot here, and then after what we can do, we have to make a metal line also for the output. Okay, so this will be V output, which is the V in bar. Okay, and if we have to draw the demarcation line, we have to draw like this. Okay, so this side our NMOS, above this it is our PMOS. So this one is also simple representation. Here a single line is responsible for both gate N of common, P is common. Okay, and but here we are writing, so both are the layout, stick diagram representation of CMOS inverter. Okay, this one we can say the demarcation line. Okay, so this is all about this video. Okay, here also we can, if we have to make, this one is our demarcation line. So like that, in the other video we will make some another diagram, uh, like CMOS NAND gate. Okay, two input CMOS NAND gate. So this is all about the layout, CMOS stick diagram, not layout. Okay, so it is very simple, but we have to very careful about this, means how, why we are making this yellow over the red is our PMOS. Okay, enhancement type. So this is all about this video. So thank you for watching this video. Thank you.